Hello, Algebra 1 students. This is Mr. Graves, and today we're going to be talking about expressing roots or radicals. Getting into that, you should have a little bit of a basic understanding of what we're doing, but we're going to expound on that, hopefully teach you some more things. So let's go ahead and get started. This is called our radical sign right here. Two examples, same thing of the radical sign. We're going to kind of expound, obviously, on it. You that are my students already know I like to use the word what. And that is the amount of root. We'll get into that a little later here in a moment. But the square root of 9 means what times what? Square root is always 2 what's, right? And that would be 3 because we know that the opposite of that, 3 squared, is equal to 9. What times what is a negative square root of 9? That would actually be a negative 3. The negative out here makes that a negative. As long as the negative's on the outside of the root, we're okay. Okay? Now, so, an example, square root of 4. What times what is 4? Well, that's 2. Square root of 16. What times what is 16? That would be 4. And then with the negative sign on the outside, we'll put a negative 4. Okay? Now, if we had a square root of a negative 4, we could not do that. Negative 4 is not a real number, and that can't be done because it's impossible to find a number that's itself, multiplied times itself, to be a negative 4. Okay? Now, we not only have square roots, and square roots, the root up here is 2 for all of these, but in square roots we generally don't write that, okay? It's just assumed, and we know that because it's square, 2. But now we have a cube root, so now we moved our what times what to our what times what times what, okay? So for the cube root of 125, what number times itself 3 times gives us 125? Well, that would be the number 5. 5 times 5 is 25. 25 times 5 is 125. How about the quad root, the fourth root of an 81? That's 4 what's. What times what times what times what gives us 81? Well, that would be 3. 3 times 3 is 9. 9 times 3, 27. 27 times 3, 81. All right? And so that's what we have for the cube root of 3. All right? Now, let's go to negative 4 up here. I believe I did that already, sorry. So you can't do that. It's gone. Doesn't work. All right? Cube root of this fraction, 27 over 125. Well, we already did 125. We know that the denominator is 5. What is the cube root of 27? What times what is 27? Well, the number's got to be the same as 3. 3 times 3 is 9. Times 3 is 27. So 3/5 is our answer. Now, in this radical problem, we do have a negative sign inside the radical. But because we have the 5th root, which is an opposite or uneven root, what times what times what times what times what gives us a negative 32? Well, that answer we can come up with, and that is a negative 2. All right? If we were to write it out, we have negative 2, negative 2, negative 2, negative 2, and one more, all right? We know that an uneven number of negative signs equals or yields a negative sign, and then 5 2's is what gives us 32. 4, 8, 16, 32, all right? Now, these two, what we're going to do is just do a little guesstimating, all right? In our own mind, let's take a look here at the square root of 129. What number, it's not an even one, but what two numbers would it come between? Let's, we know that 10 times 10 is 100. We're getting close to 129. 11 times 11 is 121. 12 times 12 is 144. And with 129 being a little bit closer to 121, we know that it's going to be 11, just a little bit over 11, and closer to the 11 than it will be the 12. That's just kind of our guesstimate. It gives us an idea. How about the cube root of 50? That's going to be a what times what times what. So we need to get ourselves 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. All right, that's the cube root. How about 4? 4 times 4 is 16. 16 times 4 is 64. All right, so now we're in between 3 and 4. And our number in here is 50, right? So we understand that we're 14 away here, but we're 23 away here, so we're a little bit closer to 4 than we are to 3. And that's kind of how you guesstimate and get a little bit of an idea, okay? Now, let's talk about powers here as they relate to the radicals. And just to give you a little bit of an idea, let me show you that the square root of 4, just over here first of all, if you just take the square root of 4, we already know that our imaginary root here is a 2, right? And we know that for every number inside has a power of 1. We can actually express radicals as numbers with exponents. And so the square root of 4 is actually written as 4 to the 1/2. The numerator is always the power inside, and for a number that doesn't have an exponent, it's always 1, okay? And the denominator in the power is always the root, whether it's squared, whether it's cubed, whether it's the 4th root, so it's 2. So we know that automatically a square root is going to have an automatic denominator of 2. So we're going to learn to write that both ways. So with that knowledge, we have 5 to the 2/3. We know that the denominator is always the power. So that 3 is going to go right there. Our base number gets put under the radical, and its power is 2. Now, we don't leave it like that because we do want to simplify 5 squared, which is 25. So our new answer becomes the cube root of 25. And that cannot be simplified. 25 is not a perfect cube root like 8 would be, or like 64 would be, or something like that. So we just leave it at that. But it is simplified, and if your homework asks that this be broken down, that's what you need to do. This one here is the opposite. We have a radical that needs to be turned into a power. So x is our base, and remember that our root is always our denominator. So our 5 goes there, and then our power is 3. So x to the 3/5 is the same as the 5th root of x to the 3rd. All right? Now, we've got a problem here, and I want to show you. I already wrote it out just to save a little bit of time. If you're given a problem that looks like this, 3 to the 1/2 and x to the 3/4, we need to basically simplify that. Well, in order to do that, we have to have our problem broken down. Actually, I kind of put the wrong list here. Let's break that down. Let's go right here, okay? And we can kind of understand what we're doing better. We'll just keep going here, all right, all the way down. And we'll draw these lines maybe as kind of steps, step by step. 1/2 and 3/4, they have different denominators, which means they have different roots, and we can't have that. So what we've got to do is we've got to find the least common denominator between the two. You know how to do that. 1/2 plus 3/4, all right? Least common denominator of 4. So look what I did. I rewrote 3 in x. 1/2 in terms of 4. 1/2 in terms of 4 is what? 2/4. 3/4 was already written in terms of 4 as a denominator of 4. So 3/4 is what I have. So 3 to the 3/4 and x to the 3/4. Guess what I can do now? Both of these have a root of 4. So now I can write it together. So 4 is our root. Look at what our powers are now, all right? Now this one didn't change, but our 3 did, okay? So I write 3 squared because that 2 is right there, okay? So 3 to the 2/4. See that? 3 to the 2/4, that's what I have. X to the 3/4, which is what I have. Now I already had it there in the original problem, but it wasn't together in terms of my least common denominator. I have to have a least common denominator because my 4's need to be unified and combined under my radical with the same root, okay? Can't have it different, all right? You got to keep it the same. So when you have problems like this with different denominators, you got to get a least common denominator. Put it all under the same least common denominator root, okay? Then this is what I have, all right? Now I need to do some simplification. I leave the x to the 3rd, but I don't leave 3 squared like that. I write it down as 9. So 9x to the 3rd becomes my next step where I simplify to the 4th root, and this becomes my answer, okay? So just so you're aware, that's what we do. Now, the last problem is the opposite of that. Take a look at this. These are a little bit easier because I have a 4th root of a 7x to the 3rd y squared. Well, the neat thing about this is when we write this as fractions all the way across, it's easy. You know why? Because our denominator for every single 7, x, and y is a 4. 4 is our least common denominator. Why? Because it's the root already. Or it's not least common denominator. It is our denominator. All right? So 4 is written as a 7. But look at the 7. There's no power there. It's just imaginary 1. So 7 becomes 1/4. X becomes 3/4. Y becomes 2/4. Okay? So I write that out. And then as you know, Mr. Graves wrote it out again. Why? Because we don't want to leave a power that can be reduced. So we wrote the first two as is, and then we reduced 2/4 as 1/2. This becomes our answer. Your homework may give you both. You might have this. You got to get a least common denominator to break it down, and then get yourself your radical. Or this, you might have your radical, and now you need to break it down into powers separately. All right? Hope that is clear to you. Hope you have a great day. We'll talk to you later. Thank you now. Bye-bye.